So from what we've learned, we're going to apply that knowledge and try to solve out these past paper questions. The first one says x squared plus bx plus q is equal to 0. And this is a quadratic equation. And it has the roots -3 and 5. We're supposed to find the value of p and q. So this equation is basically in its standard form, ax squared plus bx plus c is equal to 0. All they've done is instead of b and c, they've given you p and q. And they want you to find what these p and q are. So when you have an equation that's like this, where you have an equation and you have a quadratic equation and you don't know what the values of the b's or the c's or the a of the quadratic equation are, and instead you're given the roots of that quadratic equation, how do you find what the b or the c, or in this case the p's and q's are? Well, this is what you do. So whenever you get a question like this, whenever you're given the roots, you need to understand that using just the roots, you can actually go ahead and form your quadratic equation. And how do you do that? Well, if you realize that when we have the factorized form of a quadratic equation, it's basically something like this, which is x plus b, x plus c is equal to 0. And then you sort of, if you want to find your roots, you say, okay, well, x plus b is equal to 0, x plus c is equal to 0, and then your two roots are -b and -c. Now, remember, they've given us the roots. They said one of the roots is equal to -3, the other root is equal to +5. So what I'm going to do is basically, if you have your factorized form, you can basically find your roots, right? And what I'm going to do is I have my roots, and I'm going to get my factorized form by going in reverse. And that's basically going to be x plus 3 is equal to 0, x minus 5 is equal to 0. Okay, I just sent this thing over here and this thing over here. And now I can say, okay, well, x plus 3 is equal to 0. My bad, x plus 3 and x minus 5 is equal to 0. So I just went in reverse working, right? I just used this thing over here, and I just went in reverse working to find out my factorized form. My bad, this thing is not over here, it's over here. And now what I can do is, if you're in your factorized form, you can basically get your standard form. All you got to do is you got to expand the brackets. That's what I'm going to do. So I'm going to expand the brackets, and it's basically going to be x multiplied by x minus 5 plus 3 multiplied by x minus 5. All of this is equal to 0, and so this is going to be x squared minus 5x plus 3x minus 15, and this is equal to 0. Okay, and you can just simplify this, so this is going to be x squared minus 2 minus 2x minus 15 is equal to 0. And you can see, using just my roots, I've basically constructed my quadratic equation. And all I can do now, all I got to do now is I basically got to compare this to what they gave us in the question, which was x squared plus px plus q is equal to 0. And you can clearly see that my q is -15, and my p is basically equal to -2. So that's how you do these questions. Now, the next question says, solve the equation. And we already know from a previous equation from a previous video that whenever they tell you to solve or find the roots of an equation, you want to have the equation in the form ax squared plus bx plus c equal to 0. This is the most important part. That's how you solve or find the roots of an equation. We can clearly see this is not equal to 0, this is equal to 45. So how do we get a 0 on this side of the equation? Well, we send 45 to that other side. So it's just going to be 4x squared plus 20x plus 6 minus 45 equals 0. This thing is going to simplify to minus 39, right? And then you can basically solve this. This is basically in the form ax squared plus bx plus c equals to 0. You can apply quadratic formula on this. You can solve it using your factorized method. You can solve it using your vertex form method. I'm just going to simply apply the quadratic formula on this, which is minus b plus minus b squared minus 4ac equals 2a. So this thing is just, you now just input the values. B is equal to 20, and you say plus minus 20 squared minus 4. A is 4, c is -39, divided by 2, and a is 4, so put a 4 in there. Put this in your calculator, solve this out for the positive sign ones, then the negative sign ones. You're going to get two values for x, which are going to be 1.5, and you're going to get -6.5. Those are going to be your two values. So we go over to the next part, and it says solve 4x minus 11x 1 by 2 plus 6. So we have this equation, x 1 by 2, and we got plus 6. Plus 6 equals 0. This right over here is actually a negative sign over there, and we can clearly solve this, but the problem is this is not a quadratic equation. It does not have x squared. So how do we solve this? Now, there are some equations that are going to be in the form ax raised to the power 2n plus bx raised to the power n plus c that we can actually go ahead and treat like quadratic equations. So we can treat like a quadratic equation. And if you realize that this equation is actually in this form, how? Because, well, that bx is basically this minus 11x right over here, and then the n is actually 1 by 2. Now, the power over here is 1, right? The power on this x is basically 1. So if you realize, this 1 is actually equal to 2n. Why? Because if n is equal to 1 by 2, then 2n, what would that be equal to? Well, you just put 1 by 2 in place of n, and this is just going to be equal to 1, right? So this thing right over here, this thing is this thing, this is basically your other term. So this 1 is basically 2 times, so this is 2 times this 1 by 2. So we clearly have an equation that's in the same form as this. So that means we can treat this like a quadratic equation. Okay, but how do we do that? So remember, this term right over here, this x to the power n term, you are going to assign it a different variable. So let's say you say that x to the power n is going to be equal to a or b or c or d or e or f, anything you want to call it. I'm going to call it u. Okay, I'm going to actually, let's do this in pink. So I'm going to say that my power x to the power n is equal to u. And in our case, this equation is basically 4x to the power 1 minus 11x to the power 1 by 2 plus 6 equals 0. So this thing right over here, this x to the power n, this thing right over here, I'm going to say that this thing right over here is equal to u. And so what is x to the power 1 going to be equal to, right? This x to the power 1, what is that going to be equal to? Well, then that's just going to be u squared. And then if you don't believe me, well, look at this. So if you have your u squared, you know what u is equal to. So u is equal to this thing. So that just means that this is going to be x to the power 1 by 2. And then you have the square up there. So what's that going to be? So if you square this, it's basically just going to be x to the power 1, right? So u squared is actually equal to x to the power 1. Okay, so once we have this part done, what do we want to do? Once we have this part done, what do we want to do? Well, you replace all of the x terms with these u terms. And so this is just going to be 4u squared minus 11u plus 6 is equal to 0. You can clearly see it's a quadratic equation now. And it's obviously in the form it's not x, so I'm going to call it au squared plus bu plus c is equal to 0. So now you can solve this using your 3 methods. You can use your vertex form, you can use your factorized form, or you can use your quadratic formula, whatever you want to use. I am going to try, and I'm going to just use the quadratic formula. So it's going to be minus b, so the b is negative 11 plus minus square root b squared, so it's going to be 11 squared minus 4. You're going to have your a term, which is 4, and then your c is 6. All of this divided by 2a, so a is 4. Right, now solve this out in your calculator, once for the positive sign and then for the negative sign. So I'm going to do this for you guys. So one of the answers is going to be, oh my bad, remember, we're not going to get x. We're solving for u, right? We were solving for u. So we're going to get 2 values of u. So one value is equal to 2, and the other one is going to be equal to, so the other one is going to be equal to 0.75. 0.75. But we don't want to solve for u. Remember, our original equation had x in it. We don't want to solve for u. So what do we do now? Well, you know what u is equal to. If you look at this, you said that u is equal to x raised to the power 1 by 2. So just replace that over here. So x raised to the power 1 by 2 is equal to u, and x raised to the power 1 by 2 is equal to 0.75. Send this 1 by 2 over there. It's going to become a square. It's going to become a square, and then just square this. So you're going to get x is equal to 4, and x is equal to, if you square your 0.75, you're basically going to get 0.5625. Right? These are your 2 roots. Okay, so we got the next part, and it says 8x to the power 6, 8x to the power 6, plus 215x to the power 3, minus 27 is equal to 0, and it says solve the equation. Now we can solve this equation because it's not a quadratic, but we know that we can turn this into a quadratic because if you realize it's in the form ax to the power 2n plus bx to the power n plus c is equal to 0. And I don't know if you can see it or not, but 6 is actually 2 times 3. So if this is n, then this is 2n. And so we can turn this into a quadratic. So what we're going to do is we're going to take that x to the power n term, which in this case is this thing right over here, this x raised to the power 3, and we're going to say that, okay, this x raised to the power 3 is we're going to give it a new variable. And let's give it z. So we're going to give this z, and so what is going to be x raised to the power 6? Well, that's just going to be z squared. If you don't believe me, try it out for yourself. So we know what z is. Z is basically x to the power 3. So put that in there. You're going to have the square. So this is z squared. Plug in the value for z, solve it out, and this is going to be x to the power 6. So z squared is actually x to the power 6. And now what we got to do, well, we got to just replace all the x values with our newly found z values. So this is going to be 8z squared plus 215 z minus 27 is equal to 0. And so what do we want to do now? Well, you have a quadratic equation and it's equal to 0. You can solve it using your quadratic formula, you can solve it using your vertex form, and you can solve it using your factorized form. I'm just going to apply the quadratic formula on this, so it's going to be minus b plus minus b squared minus 4ac over 2a, and we're just going to plug in the values, so it's going to be negative 215 plus minus 215 squared minus 4 times 8 times negative 27 over 2 times 8. So you put this in your calculator, solve it for the positive sign, solve it for the negative sign, and you should get your answer. So one of the answers that you get is going to be 0.125, and then the other answers that you're going to get is going to be negative 27. Now, we don't want to find z, remember? We did find two values for z, but it's not z we're looking for. If you look at the original equation we had, we were trying to find what x is. So what do we do over here? Well, we know that z is equal to 0.125 and that z is equal to negative 27. And we want to know what x is. So that's really simple, because we said over here, we said that z is just equal to x to the power 3. So just replace that over here. So this is going to be x to the power 3 is equal to 0.125, and x to the power 3 is equal to negative 27. So you just send the 3 over there to the other side, and this is going to be cube root 0.125, and you're going to get cube root negative 27. Now you're not going to have plus and minus answers, because you only have that when you have a square root, not when you have a cube. So you don't want to put plus and minus in here. And also the other thing is that inside of the cube root you can actually have a negative number. So in a square root you cannot have a negative number, right? This thing right here is a big no-no. But when you have a cube root, you can actually have a negative number inside. So you put these two things in your calculator and you solve them out. So if you cube root negative 27, you basically get a value of negative 3. And if actually you go ahead and you cube root 0.125, then you're just going to get 0.5. So these are your two answers. Now we move on to the next question, and it says find the roots to the equation 18 divided by x to the power 4 plus 1 divided by x to the power 2 is equal to 4. So how do we solve this equation? Well, first of all, we can clearly see it's not a quadratic equation, and then we can clearly see it has fractions. So what do we do when we got fractions? Well, we're always trying to get rid of fractions. Whenever you got a problem, they tell you to solve the problem or to find the roots of the problem. The first thing you want to do is you want to get rid of the fractions. This is going to make the questions as easy for you as possible. So we're going to get rid of these fractions, write this equation in a form where it's at least more understandable than right now. So one way of getting rid of the fractions is, first of all, I'm just going to rewrite what they've given us over here. And this is one of the ways in which we can kind of get rid of the fractions. We can take LCM between these two terms and then send the x over here to the other side. So then this is probably going to be 4x something to the power. I don't know what that power is going to be, and then we just send it over here. So then all of the terms are going to be on this side of the equation, and we're just going to be left with a 0 over here. And I'm just going to do that for you guys real quick. So delete all of this, and we got 18 over x to the power 4 plus 1 over x to the power 2 is equal to 4. Take the LCM over here, so this is just going to be 18 over x to the power 4 plus x to the power 2 is equal to 4, right? Nothing crazy over here, just taking LCM. So now I can take this x squared, x to the power 4 to the other side, so this is just going to be this, and now I can drag this 4 over there, so this is just going to be negative 4x to the power 4 plus x squared plus 18 equals 0. And see, once you get rid of the fraction and you sort of arrange the equation, it's much more clearer to understand what's going on, and we can clearly see this equation is in the form ax to the power 2n plus bxn plus c is equal to 0. Therefore, we can actually go ahead and treat this like a quadratic equation. So what we're going to do is we're going to say, well, x to the power 2 is equal to, let's say, u, and therefore x raised to the power 4 is just going to be u squared. And now what we can do is we can basically just replace the x in our equation with the u's. So this is going to be minus 4u squared plus u plus 18. Okay, hope I didn't do anything wrong over there. And now what I can do is I can just solve this out like a normal quadratic equation. So I can use my quadratic formula, I can use factorization, or I can convert this to vertex form. I think I'm just going to use my quadratic formula. So it's going to be minus b plus minus b squared minus 4ac equals 2a. And so we're just going to put in the values. So b is 1, so we're just going to say negative 1 plus minus 1 squared minus 4 times negative 4 times 18 over 2 times negative 4, so that's just going to be negative 8. Now, you just put this in your calculator and you're going to get two answers, one for the plus sign, one for the minus sign, so I'm just going to do this for you guys. So one of the answers is negative 2, and the other answer is actually 2.25. It's 2.25. So these are your two answers. My bad, this is not actually the values for x, but these are actually the values for u, right? Because the quadratic equation we had, this thing right over here, this had u's in it. So we're going to get two answers for u. And we're not trying to find what u is, right? Because our original equation, if you look at this thing over here, this had x. So we're not trying to find u, but instead we're trying to find x. So what do? Well, we know what u is equal to. U is basically equal to x squared. So let's just replace that over here. So that's just going to be x squared is equal to minus 2. And then we got x squared is equal to 2.25. Now, what happens when you send the square to the other side? Well, it just becomes plus minus square root. So this is going to be equal to plus minus square root minus 2. And over here, this is going to become plus minus 2.25. Now, this thing right over here, this thing is actually going to give you no answers. Why? Because you can clearly see you have a square root, and inside the square root, you have a negative number. Okay, so this basically means no answers. No answers. You cannot square root a negative number. That's not possible. That's math error. You cannot divide anything by 0 in the same way you cannot take the square root of a negative number. So in fact, we're just going to get two answers from over here. One of them is going to be, so we're just going to square root 2.25, which is going to be 1.5. So one of the answers is positive 1.5. The other answer is negative 1.5. Now we got the next question over here, and it says that we got this 3x plus 2 is equal to 2 over x plus 1, and it says solve the equation. So obviously, we can clearly see we got fractions, so we're going to try and get rid of our fractions. And that's the first thing we want to do. So obviously, there's multiple ways of getting rid of these fractions. I'm just going to take this denominator and multiply it onto the other side of the equation, and hopefully that's going to break this fraction. So it's going to be 3x plus 2, right? This entire thing is multiplied by x plus 1, and it's all equal to 2. So now we just need to expand this. That's just going to be 3x multiplied by x plus 1, and 2 multiplied by x plus 1. All of this is equal to 2. So this is just going to be 3x squared plus 3x plus 2x plus 2 is equal to 2. Now you solve this out. This is just going to be 3x squared plus 5x plus 2 is equal to 2. Okay, so we can clearly see that we got a quadratic equation, and we're supposed to solve this. So we can solve a quadratic equation, but right now it's not equal to 0. So we actually got to get this side equal to 0. So how do we do that? Well, we can send this 2 over there to the other side. It's just going to become negative 2. And so the equation we're going to get is going to be x squared plus 5x plus 0 is equal to 0. Okay, that's the quadratic equation we're left with. So we just got to solve this now. And we can do this using the quadratic formula. We can solve this using the factorization method. We can solve this using the completing square. I'm just going to use the quadratic formula, so that's just going to be minus b, and b is 5, so this is going to be minus 5 plus minus square root 5 squared minus 4ac, and c is 0, so we put that in there, divided by 2a, and a is basically 3. Okay, so this is just, I'm going to put this in my calculator, see what I'm going to get. So this is going to be, so you get 0 out of this. So this is going to get you 0, one of the roots is going to be 0, and let me see what the other root is going to be. And then the other root is basically going to be negative 5 over 3. So these are your two answers to this equation right over here. Now the last problem says, by using substitution, by using a suitable substitution, solve the equation 2x minus 3 squared minus 4 over 2x minus 3 squared minus 3 is equal to 0. So again, the first thing we want to do is, before we even start solving the equation or finding the roots, what we want to do is we want to get rid of the fractions. So that's what we're going to do. So this right over here is going to be 2x minus 3 squared minus 4 over 2x minus 3 squared minus 3 is equal to 0. And what I can do is I can basically send this negative 3 to that side. Then I can take the LCM between these two terms, right? And then what I can do is that I can send that LCM over there to be multiplied with that 3. And then I can just, whatever the answer from that is going to be, I can take that answer over here to this side of the equation. So that's what I'm going to do. I'm just going to show you guys what that's going to look like. Of course, there's going to be a lot of ways you can get rid of these fractions, but I just think I'm going to do what I said. So I'm going to show you guys what that's going to look like. So I send the 3 over there to the other side. I take the LCM between these two terms. So I have a 1 over here. That just means this is going to be 2x minus 3 whole squared, over the LCM is obviously going to be 2x minus 3 whole squared, and then it's going to be 4 over 2x minus 3 whole squared is equal to 3. And then see, this is this is the LCM, right? This 2x minus 3 over 2, this is the LCM. So obviously I have to multiply the numerator with that as well. So I'm going to multiply the numerator over here, and you can see that this entire bracket is the same as this entire bracket. So it's like asking yourself this question, okay, if you have an a to the power 2 and it's being multiplied with another a to the power 2, what's the answer going to be? Well, the answer is just going to be a to the power 4. So it's almost like, imagine this bracket was an a and this bracket was an a as well. So what's going to happen? Well, the answer is just going to be 2x minus 3 raised to the power 4, and then in the denominator you have the LCM, of course, 2x minus 3 squared, and you have all of this. So I'm going to send this denominator over there to the other side, and that's just going to be 2x minus 3 raised to the power 4 minus 4 equals 3 times 2x minus 3 raised to the power 2. Now I'm going to send this over there, so that's just going to be 2x minus 3 raised to the power 4 minus 3 2x minus 3 whole squared minus 4 equals 0. So right now all I've done is I've just gotten rid of my fractions. That was my first step. Get rid of fractions. Okay, and once I did that, I just rearranged. So I just rearranged my equation. And you can clearly see it's much more understandable, much more clearer, much more readable right now. So if you notice, this question is exactly the same as the questions we've been doing before. So right, all of this is the same as all of this, right? So the brackets are the same. It's just that they have different powers. And this power, this 4, is actually 2 times that power. So what is this? Well, you can kind of realize that this is actually the same problem as ax to n plus bx to the power n plus c is equal to 0. It's exactly the same problem. This bracket is exactly the same as this bracket. It's just that they happen to have different powers. This has a 4, that has a 2, and we know that 4 is 2 times 2, right? So it's exactly this case right over here. So what we can do is we can basically say that, okay, this term 2x minus 3 raised to the power 2, this is equal to some new variable, right? Let's call that variable t. Okay, and so that means that this 2x minus 3 raised to the power 4 is basically equal to t squared. And now what we can do is we can just put these t's in the equation, so it's basically just going to be t to the power 4 minus 3 t. Wait, my bad. This is not right. This is right. Okay, and then we got the minus 4 over here is equal to 0. Okay, so perfect. And now this is clearly a quadratic equation, and so we can go ahead and solve it out. And I'm just going to use the factorization method. So we got over here we got a 1. So 1 times negative 4 is equal to negative 4. Now we need two numbers that are going to multiply to negative 4 and that are going to add up to the negative 3. So those two numbers are negative 4 and positive 1. And then I can just write those numbers over here. So it's going to be t squared minus 4t plus 1t, or 1t is just t, minus 4 equals 0. Okay, now all I got to do is I got to take common. So it's going to be the first common is t, and then I'm going to be left with t minus 4. And then I can take plus 1 common from over here. So I take plus 1 common and I'm left with t minus 4. All of this is equal to 0. So this is going to be t plus 1, and t minus 4 is equal to 0. So one of the roots is going to be one of the roots, hold on. So it's t plus 1 equal to 0, it's t minus 4 equal to 0. One of the roots is going to be minus 1, the other root is going to be plus 4. Okay, but I don't want to find out what t is going to be, right? That's not my problem. I need to find out what x is equal to. So what is t? I know what t is. I know what these t's are. I know that t is actually equal to 2x minus 3 whole squared. So I can just replace that over here. 2x minus 3 whole squared, right? And then 2x minus 3 whole squared is equal to 4. And what's going to happen when you take these squares to the other side? They're basically going to be plus minus square root minus 1, and then over here we're going to have plus minus square root 4. Now we're going to get no answers from this. And why is that? Well, because we got a square root, and inside of the square root we have a negative number. So that's not possible. That means no answers from this part. No answers from this part. This is impossible. And over here we're going to basically get two answers. One's going to be for the plus sign, one's going to be for the minus sign. We know that square root 4 is basically equal to 2, so it's going to be 2x minus 3 is equal to positive 2, and 2x minus 3 is equal to negative 2. And then remember, we're trying to find the x, right? That's what we're trying to find, the x. So we're just going to make x the subject in both of these equations. So this is going to be 2x is equal to plus 2 plus 3, and this is going to be 2x is equal to minus 2 plus 3. So over here, we're actually going to get 5, and over here we are going to get positive 1, and then we're going to get our answers, which is going to be 5 by 2 and 1 by 2. So these are the two answers to our equation.